Well, hello and welcome YouTube, Mr. Robinson back with you with another brand new exciting video, all math-based of course, and as always, it is an honor and a privilege to have you join me as I teach you a little bit of math stuff. Today, we are looking at some practice problems for solving for a variable. You might say like, well, you always solve for variables, it's all algebra. Yeah, but this time there are going to be a lot of variables in the way. It's going to be almost all letters, maybe a number or two in each problem, but we're not solving and getting x equals 7, now we're getting x equals AB minus C all over E to the F power of G. It's gonna be pretty straightforward here. It is for Algebra 1 classes, and I'm not yet doing square roots or exponents. So it's a lot of inverse operations from addition, subtraction, multiplication, and division. I'm actually not even doing any problems that's going to involve factoring. I just want to make sure that people can see how we end up. Let me show you the problems. I just want to make sure that people can end up and see how we can get an answer by itself, a variable by itself when it's with a lot of other stuff in an equation. So here's the breakdown of this, and here's what's happening. You're going to be asked for solving the indicated variable in each mathematical formula. Now, interestingly enough, all of these actually do represent actual math-based formulas, and I'll even tell you what they are when we run into them. These are as they are written in their most general sense. So like, this is how you'd see them as you would study for them. But what we're going to do, see, like this equation in number 1, C is the variable that's by itself. We have solved for C in this equation. So when it says solve for the indicated variable, right now C is the one that's solved for. Here's the equation. C is solved for. What we're going to be asked to do is solve for a different variable in the equation. Basically, get it by itself. Isolate it. So you're going to use inverse operations on both sides of the equation to just make sure that you express it with that variable isolated in terms of any of the other variables that are present. And because these are actual math formulas, I'll even tell you what they actually solved for. I'm not going to do a lot of other example stuff with it. I want to get through them. I got 16 problems to do with you. The first 10 are real life formulas. The final 6 are just, I think, made up things, but we can just practice with them and see what we get. All right, let's go ahead and get started. Now remember, no actual numbers in this word. I mean, there's some numbers, but we're not going to get just a point blank answer. That's not the point. The point is if you substituted something in for the other variables, that's what we get. All right, so number 1. So the equation is C equals 2 pi r. Now this is an equation meant for finding the circumference of a circle given its radius. If you know the radius, you can find the circumference. Pi, which you'll see in other equations like this one and this one, pi is a constant. 3.14 is the approximation, but it's not a variable. It doesn't change. It's a number. They just don't want to write 3.141592653. Like they don't want to keep going with this whole thing like that. It's a never-ending, never repeating irrational value, so a constant works for it. All right, number 1, let's go ahead and solve for r. Let's get r by itself. I'm going to rewrite this again really quickly, just a little bigger, because I'm going to separate and note that the idea that 2 is multiplying with pi, which is multiplying with r. If I want to get r by itself, I'm going to go ahead and use inverse operations of what's affecting r and in what way. 2 and pi are affecting r on this side of the equation in the way that they are both multiplying with r. So if I decided to use the inverse of multiplication, which is division, and if I divided both sides by 2 times pi, like this, then what I will get is a coefficient of 1 in front of r, because 2 over 2 is 1, pi over pi is 1, so now I get 1r. This ideally solves for r. My equation can now say r equals c over 2 pi. And that's it. That's the answer. We solved for r in terms of c. Or better yet, because this is a real equation, for a circle, instead of finding the circumference based on the radius, I can now actually find the radius of a circle based on the circumference. You take the circumference and divide by twice pi. Cool? Go ahead and jump into number 2. Number 2, a equals 1/2 bh. Let's solve for b. This happens to be the formula that helps you find the area of a triangle. A stands for area. In this case, B, lowercase b and h. These are the base length and height length of the triangle that you're given or that you can discover. And then you take half of it and you get the area. So let's go ahead and solve it for B. Now, just like the last problem, I'm going to rewrite this again to make sense of the idea that everything here is multiplying. If you can't see the operation in between, then it's multiplication in these instances with these variables. Now I got to get b by itself. And just maybe, unlike the other equation, see in this equation, if I decided to say, hey, let's divide by this 1/2 because that's multiplying by b, and let's divide by this h because it's multiplying with b, you could do this. But part of the issue, you can probably notice it here. Notice how I divided by 2 pi and it was still kind of just divided by 2 pi. That's fine, but I don't want to write my answer as b equals a over 1/2 h. I never want a fraction within a fraction. And that's not me. That's kind of not allowed. It's not really, that's not how we go about solving these problems. So you can't have a fraction within a fraction. Now there are remedies around this, even with writing it this way, for which you might understand. But for this particular problem, I want to make sure that the fraction idea is understood in multiple iterations. The first way that I can speak about it is that 1/2 is 1 over 2. So one way I could represent this instead is say that, hey, b is really b over 1, h is really h over 1. If I multiply these things out, 1 times b times h, I get bh, and 2 times 1 times 1, I get 2. So it really kind of goes in the denominator. It's really like 1/2 isn't multiplying with bh, bh isn't multiplying by 1/2, but it's also dividing by 2. And the only reason I bring that up is because if we're all about doing inverse operations, well, if b is dividing by 2, then to get 2 out of the way on this side of the equation, I could multiply both sides by 2. And then effectively 2 over 2 becomes 1, and the 2 is gone on that side of the equation. And that's a perfectly valid way of going about it. You don't have to rewrite it as a fraction, but understand that it is dividing by 2 here, and that's what you can do. No problem. That's one way. Second way, and remember all these are the same thing, but second way is this. Remember the dividing by the fraction thing? Do you know how to divide by a fraction? And I'm asking, I want you to say this to yourself. How do you divide by a fraction? When I divide by 1/2, what is that the equivalent of doing in multiplication form? The answer is you're multiplying by its reciprocal. 1 over 2 has a reciprocal of 2 over 1. Dividing by 1/2 is the equivalent of multiplying by 2 over 1. So what I could do is go back to this thing, and instead of writing divided by 1/2, I'm going to say it the other way. Let's say I want this thing to go away, right? Normally we cancel them by something that's, dividing and multiplying. So what if I multiply by its reciprocal of 2 over 1? What happens is 2 over 2 becomes 1, and 1 over 1 even becomes 1. I don't know if I have to cancel those out, but the point is those cleared each other up. And this might be a better practice to use, mostly because you don't always divide 1 by 2. It could be 3 by 2. So I'd multiply by 2/3 and make that happen. Regardless, 2 over 1 is still 2. So notice no matter what I'm doing, I'm really multiplying both sides by 2. That helps clear that portion up. And you've taken care of it in that stage. But I got to multiply by 2 over 1 on this side as well, before I forget. And 2 times a is a. Is 2a, and 2a over 1 is 2a. So what I now have in this equation looks like this. 2 times a is on this side, no matter which part I look at. I have 2a, and this is equal to b times h. I'm just going to go ahead and write bh. Now I didn't do anything with h in that first step because I wanted to focus on the fraction bit there. That's what made this problem different from the last problem. b is multiplying by h. Let's go ahead and divide both sides by h. h over h is 1 right there, so now you have 1b, and that's what we're looking for, of course. 1b equals 2 times a all over h. 2a over h. That's the answer to that one, and of course this was all about area of a triangle before. You could find the area of a triangle if you knew its base length and its height. Guess what? I could find the base length of any triangle if I knew its area and its height length. I could double the area divided by the height length. Boom, you get your base length right there. That's how you can find it. So rewriting this is just, it's working several things. I like that they're using real context for it. It's kind of cool, even though I never actually write it this way. This is still something that you can do, you're able to do. That's how math runs. All right, number 3. y equals mx plus b for x. Now, if you've ever been in any sort of algebra class before, you've probably seen this one. It's a lot of people's preferred appearances for graphing lines. This is called slope-intercept form for a linear equation, where m represents the slope of your line and b represents what's called the y-intercept of your line. So we're going to solve for x. X and y, which are variables in your equation, they change all over. If x is something, y changes with it. Let's go ahead and get x by itself. Now this problem is different from the others because there is an extra term that is added with the x term right here. And this is affecting it, again, through addition. But this is a lot like a two-step equation. This could be like an equation that says 12 equals 3x minus 9, like that. And if I said solve for x right here, the first thing I'm going to do is get rid of this constant that's on this portion of it by doing an inverse operation. In this case, it would be plus 9 on both sides because it's subtracted. In this case, it would be minus b on both sides. If b is adding here, I'm going to go ahead and subtract it from both sides of the equation like that. B minus b is 0, so that's canceled on that side. And down below, now it looks like we have y minus b, which becomes what? Well, they can't combine, so I'm going to leave it as y minus b. And all that equals that m times x. That's all that's left there. Remember, the goal is to get x by itself. Isolate x by doing inverse operations. That's why I moved the b over. M is multiplying with x. Much like the other problems, I'm going to go ahead and divide both sides by m. Just keep in mind that when you divide by m, it can't just be with one term. It would have to be with both terms. And a better way to write that is with a common denominator. Not two different fractions here, just one big all over m like that. And that works out, and I'm just going to rewrite it one more time. We're getting x equals y minus b all over m. So you're finding one of your points in your equation by taking the y value of that point, subtracting the y-intercept, and dividing by the slope. Did I know that, all that off the top of my head? No, I'd have to do a rewrite and tell you that. But we got it solved in that way. You can find x values that way each time. You're golden. And that's what we're doing for all these problems here. So I'm going to speed up a little bit more with these. Now that you've gotten an instance of what happens, hopefully we've used all the inverse operations to make them happen. Sometimes problems are represented a little more differently though, and it's going to become a little harder to see. So let's go ahead and get started. Number 4, a equals 1/2 quantity times the quantity a plus b, closed quantity, times h. Let's solve for h. Before anything else, and it took me a moment to go, what the heck is this equation? This equation is finding the area of a trapezoid if a were one of your bases and b was your other base. There are different ways that you see this equation. One that would tie in very closely is if you used b1 and b2. So you go, oh yeah, I've seen that. Or b1 plus b2 all over 2 times h. A lot of different ways you can write it. Notice 1/2 is also dividing by 2. So a lot of different ways that you can write it. But this is finding the area of a trapezoid. All right, that's what the equation is. These are the two bases of your trapezoid of different lengths. You can't have two trapezoids of the same base length. And the height of the trapezoid, the height that separates the two bases. We're going to get the height by itself here. And we have all this stuff. Now, what someone might think to do here is, especially if you've been practicing it, hey, I can distribute these things right here. And it's not to say you can't. And like, hey, I can distribute the h into here. Again, not to say that you can't. But the goal is to isolate h. Don't make things more complex on the side that you're trying to move things over to. If you want to simplify on the other side, that's up to you. But I just want to get h by itself. Okay, so distributing all that kind of stuff is a little nonsensical to me. If you make sense of the fact that everything here on the right expression is multiplying. 1/2 is multiplying with the quantity a plus b. You might say, hey, these are adding. Yeah, but it's quantified. So that quantity is multiplying with 1/2 and with h. Once again, we want to use inverse operations of what's happening here in order to get your solution, get h by itself. And we've seen a 1/2 before. Even though it's multiplying, you could say divide both sides by 1/2, but that's the same thing as multiplying both sides by 2/1, just like that last problem. In fact, this don't look much different when all's said and done there. 2/2 is 1. 1/1 is 1. Now all I have is that a plus b times h on this side, and on this side I have 2a. So with 2a equals a plus b quantity a plus b, times h. Okay. Now we have to divide both sides by a plus b. Because a plus b is quantified, I'm not going to distribute. I want h by itself. Because a plus b is quantified, and it is a multiple that exists on top, dividing this sum on top and bottom will allow to cancel. It's like dividing 3 plus 7 by 3 plus 7, understanding that they are grouped in their respective numerator and denominator. So they can become 1 through that cancellation. So I have h by itself here, and h happens to equal 2 times big A divided by little a plus b. There's an important distinction to be had here. The big A and the little a actually do mean different things. If you have equations and you have a capital A and a lowercase a, they don't mean the same thing. They might not mean the same thing in any instance whatsoever. What was big A? Area of trapezoid. What is little a? One of your two base lengths. They're not even the same dimensionality. This is a single dimension unit. This is a two-dimension unit. Okay, so we found the height in terms of the trapezoid's area and its two base lengths. Okay. All right, number 5. V equals pi r squared h. Solve for h. You've probably heard of pi r squared before. Pi r squared is finding the area of a circle given its radius. So pi r squared times h is actually, it helps you find the volume of a cylinder. If you don't know what a cylinder is, I'm going to draw that part out. Cylinder is, let's say there's a circle down there. Think of like a soda can. A cylinder is one of these, sorry for the drawing, but a cylinder is like a big, it's like a Pringles cup. And this is transparently, you're looking behind it right there. So here's like the circle on the bottom. Here's the height of that cylinder right there. So we're trying to find the height of the cylinder given V, its volume. So what this equation is about, finding the volume of a cylinder given the radius and the height of it. How much can fill inside of it? How much soda can you put in it? How many liters or cubic, cubic centimeters? So solve for h. This one's pretty straightforward. I'm not going to say much to this. Everything's multiplying by h. Pi is and r squared is. Doesn't matter that r is being squared. It's still something that's multiplying by the others. You would square first anyway before you multiply, so just treat r squared like any of the others. But pi and r squared are both multiplying by h, so let's just divide both sides by pi r squared. And boom, there it is. Those kind of cancel. And then you get h equals v all over pi r squared. If I take the whole volume of my cylinder and I divide it by the area of that base circle on top or bottom, if I divide it by its area, pi r squared, I get the height of the cylinder. All right. Number 6, SA equals 2 pi r squared plus 2 pi r h for h. Now, what's interesting to note about this one is SA actually does not mean S times A. This SA here is actually one variable. It stands for surface area. So it's not that this is something and this is something else and they're multiplying. This actually is just surface area. And I think there's another equation that does that, number 9, as I'm looking at it, does that as well. So surface area equals, now what is surface area? It's like, this by the way is for a, also for a cylinder. Surface area means the outside coverage of the thing. What's the area if I were to like put paper all over each part, the round part in the top and bottom? This is a surface area of a cylinder, but we want to find the height. We want to find h, we want to get it by itself. There's only one h variable in this entire thing, and it's all the way at the end. Notice that it's also multiplied by 2 pi r, and that's all adding with 2 pi r squared. So a lot like problem number 3, it really is just a variable here, a variable, or a term here, if you will, and a term here. And I know I'm getting messy. I'm just showing you. It's really just things that are just being added, and we just got to move things over, little bits at a time. So if h is all the way in this term here, let's go ahead and get this whole thing isolated by moving this to the other side, 2 pi r squared. I'm going to subtract 2 pi r squared from both sides of this equation like this. 2 pi r squared minus 2 pi r squared is 0. And now I have an equation that says SA, surface area, minus 2 pi r squared. By the way, 2 pi r squared are the areas of the two circles on top and bottom. So those are the two areas there. Equals 2 pi r h. And 2 pi r h is actually the surface area of the side part. You probably can't see my hands. The side part of the cylinder as you're doing that right there. We got to get h by itself. 2 and pi and r are all multiplying by h. So I'm going to divide both sides by 2 pi r. 2 pi r. And remember, over here, everything gets divided by 2 pi r right there. Okay? So you get h equals SA, surface area, minus 2 pi r squared, the surface area of both, or the area of just the two circles, all divided by 2 pi r, which in essence is the circumference of those circles. And that's how you get the height of your overall cylinder. Now, there might be a question being asked right now about, can these things cancel? No, they cannot. And I'm going to undo it right now. They cannot. I can't get into huge explanations as to why. Well, number one, this one says squared, this one does not. 2 pi r is not a common multiple on top and bottom. It's not a common multiple. These are two separate terms. SA has to be included if you're going to be doing cancellation-based things. They cannot cancel. There's a difference between what's happening here, common multiple, and here, separate terms. That's as much as I'm going to get into it, but you cannot do this. Even if you could, they wouldn't disappear. They would probably become one somehow. They cannot cancel. All done with that. All right. Solve for the indicated variable in each scientific formula. Okay, a little less math-based, a little more scientific-based. Here we go. You can use these. Obviously, they're math-based things, but here we go. D equals RT for T. All right, probably the easiest equation of all the things we're going to do here. First of all, this is distance equals rate times time. And this can be used for a lot more than just covering distances. It could be the amount of work done, the amount of items completed, the amount of whatever. Distance equals rate times time. You drive 80 miles per hour for 2 hours. 80 times 2 equals 160. You've gotten 160 miles. That's what that is. All right, solve for T. Divide both sides by R. Not even going to write the divide both sides by R. I'm just going to write out your answer. T equals D over R. Time taken equals distance divided by average rate. Okay, that's it. Isolated T. Number 8, PV equals nRT for T. Okay, so for this one right here, this is a scientific equation involving pressure. I think it's called the ideal gas law. P is the actual pressure of it, and then V is the volume. N and R. N is the number of moles of gas. This is something it's more for chemistry. R is a constant. It's a gas constant. I don't know what the actual number is. Pi is 3.14. I don't know what R's is. And T is the it's the absolute temperature. And absolute temperature means temperature above absolute zero, and it's measured in Kelvin. Absolute zero is scarily cold. It's 0 degrees Celsius is what is Kelvin 273 something degrees Celsius above the Kelvin. So I don't know. It's absolute zero is just you can't get colder, I guess. Anyway, let's solve it for T. Now this is P times V, by the way. They're two different things: pressure, volume. Okay, these are all multiplying. What this is? Let's go ahead and do this. I'm wasting time talking about the things. Am I? I want you to know what all these things are. I'm going to divide by n times r on both sides. Remember, they are two different terms, n times r times t. Divide by it there, you get t by itself. We're going to end up saying t equals pv over nr. You can get the absolute temperature of your gas by taking gas's pressure times its volume divided by the number of moles of that gas times that constant, the gas constant, which of course is the same for all gases. Whatever it is, I can't remember. Okay, number 9. A equals FV minus OV, all divided by T. In this case, FV doesn't mean F times V. So this kind of sucks sometimes that you're not able to figure out, specifically like what they are with that. FV is, so this whole thing has to do with velocity. This is average velocity. You can average something's velocity by taking the final velocity minus the initial velocity and dividing it all by time. And you have now averaged out what all your velocity thingamajigmers are. I think it's final velocity. Maybe it's final acceleration, now that I think about it. Regardless, I might have messed that one up. Regardless, final velocity FV is one variable, same as OV. We're solving for OV, so original velocity. Okay, so you take A, so I'm trying to say average velocity. Might be average acceleration now that I think about it. Okay, so here we go. This one's a little bit different. Here, I'll have to write this again. This one's a little bit different because, well, it's not. But this time there aren't any numbers involved. And I really want to eliminate the fraction first. If the whole goal is to get this thing by itself, notice what's happening. It's being subtracted from final velocity, or FV, and it's all being divided by t thereafter. So t is kind of the first thing I want to take care of. Let's get rid of that fraction in this whole thing. Let's multiply both sides by t. If t is dividing among these guys right here, you multiply by t, so t over t can give you that 1. It's gone on the right expression, and it exists on the left expression multiplying with a. I'm going to go ahead and put a first just for alphabetical purposes. So a times t equals, I'm going to put them with a little dot, a times t equals fv minus ov. OV is still on the side of the equation with the FV right here. FV is positive. You could say it's subtracting out OV. There are multiple ways to do this problem here. You know, I'll kind of go a different way this time. I want to get OV by itself, but remember it says for OV, not negative OV. Notice how OV is being subtracted. I need to make it positive. So one thing I could do is instead of trying to get OV by itself and moving everything else over, maybe I move OV over to the other side because I need to make it positive, you know? So what if I add OV over to this side of the equation, like that? And remember, these don't combine, you know? But what I get, in essence, right here, and I'm going to move that AT over afterward, but I have OV plus AT, A times T, equals FV. Now I'm going to go ahead. This A times T is adding with OV. Now I'm going to move that over to the other side of the equation. So a lot of moving over. That's fine. Minus AT minus AT, A times T. So OV, the original velocity, boom, equals FV, the final velocity, minus average, I think it's, knowing my calculus, that has to be average acceleration. I must have said it wrong when I said velocity. Minus A times T. And T is time. So there you go. That's the final equation there. Remember, it needs to be a positive OV when you're getting that one solved. Another way you could have done it, I could have subtracted FV over, but then I'd have to multiply everything by -1 and then switch signs, so I'm going to stick with that one. Okay, number 10, C equals, now there's a big C right here, and there's a lowercase c right here. Hopefully you can see the different sizes, because they don't look different, unlike a lowercase a and capital A. Big C equals W times little t times little c, all divided by 1,000. We want to solve for W. Okay, so in this particular instance, again, W is multiplying with these guys, dividing by this. These things, by the way, this is to find the cost. This one's weird. Electrical devices have a certain amount of cost applied with electronic devices here. The big C is that total overall cost of it. W is the amount of wattage that's used. T is the time. I think it's hour in hours. Hour time that's being represented. And little c this time is the cost in cents per kilowatt hour. Weird, right? And when you divide by 1,000, that gives you the total cost. It's just total cost of operation of an electronic device. There you go. I'm going to use a different color because this other one's leaking over. Let's go ahead and get that separated. W by itself. I want to take care of the fraction first. Me no likey fraction, you no likey fraction. We get rid of a fraction. Multiply both sides by 1,000. Can you do that in your head? Multiply by 1,000, it's gone on this side. Multiply by 1,000, it's on this side. 1,000 times C, big C, by the way, equals capital W, lowercase t, lowercase c, right there. We have to get W by itself. It's multiplying with T, which is also multiplying with C. So let's divide TC on both sides. Notice TC will go away on this side and it will exist still on the bottom on this side. We're going to get W equals 1,000 times big C, all divided by lowercase t, lowercase c. So notice how I tried to differentiate between the two. These c's won't cancel. They're not the same thing. This big C's total cost, This one is like a cost in per hour. Yeah. So the total cost, by the way, is also in cents. The cost you get here is in cents. Okay. I got 6 more problems. These don't have real applications tied with them, but hopefully now you're making a little more sense on what's going on with these. Let's get her done. Number 11, 2p plus 5r equals q. Q is solved for. I want p to be solved for. Let's get this 2p expression by itself by subtracting 5r from both sides. Minus 5r minus 5r. We're going to get 2p equals q minus 5r. I got to get p by itself. 2 is multiplying with it. So let's divide both sides by 2. That sucker right there. And we will go ahead and get p equals, remember 2 over 2 is 1. P equals q minus 5r, all divided by 2. Okay? We have solved for p. We've gotten p by itself. No real equation, but there you go. Number 12. Negative 10 equals x, y plus z. We solve for x. Get x by itself as it multiplies with y, and z is added with it. Z is added with it kind of in the last stage, so let's subtract z from both sides to start. Move that term over right now, and you'll get negative 10. Let's do negative z minus 10 equals x times y. I'm going to go ahead and divide both sides by y to get x by itself. And in that case, I'll write it. I don't trust that you can do that all in your head for this one because there's a lot of stuff in the way. And in that case, I'm going to go ahead and get x equals negative z minus 10, all divided by y. This answer is fine. It's fine. But because, and you know, I'll tell you a better looking answer. My class won't understand why because we haven't played with factoring, and even some other people would have trouble with it. I'm going to put the negative way out in front right here and make these terms on top positive, like z plus 10 all divided by y. There's a reason behind that that makes it a little more formal looking. This answer is fine. I'm going to box both. If you saw an answer in the back of a book, you might see this, though. It's all about all those terms being negative on top. It's something that they kind of frown upon. Either or. Great. Number 13. A divided by B equals C. Let's solve for B. Now, B is in the denominator. Okay? When you're solving for a variable and it's in the denominator, we can't just say something like, let's divide both sides by A. Maybe that happens somewhere, maybe not. But even if you did, it's not like B just is by itself in the equation without anything else, just B equals, because B is still in the denominator. So I have to make sure that B is in the numerator for this thing before I start anything else. So when A divided by B equals C, let's get B back up in the numerator. How? If it's notice what happens when something's being divided. What we end up doing is we multiply both sides by that denominator, and even though it cancels on one side, it exists now on the other side. So even though the B's are gone here, which is good, me no likey fraction, A equals C times B, or A equals B times C for alphabetical purposes, I now have it in the numerator right here. So there's B. Now I just got to get it by itself. It's multiplying with C. Divide both sides by C, even though I like the look of this equation now. This gets B equals A over C. Okay. There's our answer. There's our practice. All right, number 14, solve for J. Looks a heck of a lot like the previous problem that we just did. H minus 4 over J equals K. Solve for J. In the denominator, have to get in the numerator. Bar none, start off with it. Why not? So multiply both sides by J. You can see J over J is 1 on this side, but now J exists over here. K, J, H, I, J, K. So I'm going to put J first. I like my alphabetical way. So H minus 4 equals J times K. Divide both sides by K, and remember, divide every term here by K like that. So we're going to get J equals H minus 4, all divided by K. There's your solution for that one. I'm just speeding up now because I noticed my time is whizzing. Number 15, x divided by 5 minus g equals a. We must solve for x. excuse me, there are two different ways that I would recommend going about solving this problem. One has to do with clearing the fraction first, the other has to do with clearing the fraction last. For this particular problem, I'm going to do it last. There are some instances of problems where it's better that if you don't like dealing with fractions to begin with, then you would take care of it immediately. But in other problems where these are actual numbers and you could combine like terms when you move something over, it's probably best you save it for the end anyway. So x is being divided by 5, but I'm going to go ahead, because minus g is happening here, I'm going to add g to both sides right here. A plus g, of course, does not combine, so that's still a plus g, but it's going to be on that side. So x divided by 5 equals a plus g. Okay, now to solve for x, as it's dividing by 5, I need to multiply both sides by 5. But keep in mind, just like when you divide both sides by something, you better make sure that every term in the other equation gets multiplied by 5. Don't just write this. Why not? Because right now only g is multiplying by 5. I need this side of the equation to multiply by 5. And unlike division, where you don't need to write anything else to indicate a grouping except just a big fraction bar, for multiplication, you might want parentheses around that guy like that. Okay, so this answer can now say, as 5 over 5 is 1, you can say x equals, I want to put the 5 in front, you know, like when you distribute, kind of have in front, 5 times the quantity a plus g. That could be an answer. That's just fine as an answer. An alternative could be distributing the 5, just so you see it. X equals 5 times a plus 5 times g, like that. This one is simplified. This one is factored. They both work. The equation doesn't represent anything in particular anyway. I got x by itself. They're good to go. But 5 better multiply by both, not just by g or just by a. It's got to be by the whole quantity or both separately like that. Okay, the very last problem. 5p plus 9c equals p for c. This problem kind of reminds me of, I wish they did the Fahrenheit and Celsius conversion one, because that has a 9/5 in it, I think. So solving for c, get it by itself. This one here, the 5p term is like affecting it, so let's subtract 5p from both sides. And ooh, take a look. P minus 5p is going to happen here. So am I just going to write p minus 5p on that side? No, because like terms can combine. P and 5p, or p and negative 5p, can combine. P is also 1p, if you think about it. So this is 1p minus 5p. And 1p minus 5p is negative 4p. So 9c equals negative 4p. We want to get c by itself. That's why I did the subtraction. 9 is multiplying with c. So my very last step, my very last problem, I'm going to go ahead and divide by 9. And we are going to be getting here c equals negative 4p over 9. You also might see it something like negative 4/9 p, something like that. Either or seems to work out. I'm good with it. I'm good with it. Any of those answers can work there. So that's what all this stuff is about here, solving the equations. I'm not going to say that they get necessarily very, well, the problems can get harder, but this idea, as long as you understand how inverse operations work, and especially fractions, I think just clearing the fractions really gets you to go. Just make sure you don't combine like terms when they shouldn't, but do it when they should, and I think all will be squared away. All right, so that'll do it for this video here. I overstayed my welcome. Hope you enjoyed this, and for now, I'll see you later.